Why do we do this? Why do we need to have these structures? Can we predict and prevent every problem in a program? Because if we can, we could just preemptively get ahead of this, right? Bunch of if statements and handle it. And that's the concept of defensive programming, making sure that the data is as good as possible before you even try to move forward with it. So let's imagine a program. I gave you an infinite amount of time, and you are going to be able to get any piece of software, and I want you to tell me, does this complete or does it not complete? Will I run into a problem where this will loop forever, or will it at some point complete? So if you can do it, you can write a program that does it. So let's write a program that does it. And then a second program that takes the output from the first and does the opposite. So if the first program determines that the code will complete, the second program will enter an infinite loop. And if the first program determines that the code will not complete, the second program just quits and it's fine, okay? So we've got two programs, we're going to bundle them together into one program. And we're going to take the code from those two programs, write that combined program, and feed it into itself. So the question is, what will happen? Well, if the combined program thinks that it'll complete, excuse me, then the code loops infinitely, right? If the first part says it'll complete, then the second part loops infinitely. So then that means that it loops infinitely, which means that the first part will know that it loops infinitely, which means that it says it won't complete, which means that the second part will complete. But then that means that the first part will know that it completes, so the second part will loop infinitely. You can see the problem we get into. This is a paradox. Paradox forms no matter what we do. And this is the proof that Alan Turing came up with to the halting problem. He proposed this proof in 1936, and it proved that some things are unknowable. You cannot answer ahead of time certain things. For us, this means that it's impossible to determine and prevent all issues with the code before we start. So we might as well be flexible and understand that there's going to be some things that we can't predict ahead of time. So maybe we can kind of put some stopgaps in. So what does this mean for us? What can we do? Well, we can put some if statements around questionable code, proactively try to prevent issues, like we said. If we see a situation that's bad, we can raise an exception, and we've already seen how we do that. Raise, exception type, and then parentheses with the error message. Do use that error message. It does help. Okay. And this is going to be useful whenever we encounter system states that may not be preventable, but might be predictable. We can't prevent a database from going down, but we can predict that a database might go down. We can't prevent a file from being missing, but we can predict that a file could be missing. And so let's check for the file's existence beforehand. And then if it's not there, let's handle that accordingly.